Welcome back, dear grade 11 students, and now we are going to talk about a new idea. We are going to talk about the discriminant that's usually denoted by delta. So this is the symbol of the discriminant. It's delta. Its formula is b squared minus 4ac. What are b, a, and c? Remember, the quadratic equation has the form of a x squared plus bx plus c equals 0. So delta, this discriminant, is equal to b squared minus 4ac. That should be memorized very well. So delta equals b squared minus 4ac. Example. Determine the discriminant of each of the following quadratic equations and find its sign. And later we are going to know why do we really care about the sign of delta. X squared minus 3x plus 2 equals to 0. Here a is 1, b is minus 3, and c is 2. Then delta equals b squared minus 4ac, which means applying the rule and evaluating the numbers, minus 3 squared minus 4 into a, which is 1, and c, which is 2. And finally the answer is 9 minus 8, which is 1. Here delta is positive. X squared plus 6x plus 9 equals 0. A is 1, b is 6, c is 9. Then delta is b squared, which is 6 squared, 36, minus 4ac, which is minus 4 into 1 into c, which is minus 36 also. Then delta is 0. So delta may be positive, it may be 0, and here you can see that it may be negative. Delta here is, we have x squared plus 4 equals 0. Note that b is 0 here, and that's possible, never mind. So a is 1, b is 0, and c is 4. Then applying the rule, delta equals b squared minus 4ac, which is 0 squared minus 4 into 1 into 4, which is negative 16, which is less than 0. Then delta may be positive, it may be 0, and it may be negative. Can you find a relation between the sign of delta and the number of roots? Here what we are going to talk about in the coming slide. Solving ax squared plus bx plus c equals 0 using delta and knowing the number of roots. If delta is positive, then there are two distinct real roots. So that's why we care about the sign of delta, because the number of roots is related to the sign of delta. And here is the first rule. If delta is positive, then we have two distinct real roots for this equation. X prime is the first root and x double prime is the second root, or we can call them x1 and x2. Now we have also to memorize this rule. So till now we have two rules to memorize. Delta equals b squared minus 4ac, and here comes the rule related to the roots x prime and x double prime. X prime is equal to minus b, this, plus radical delta. So after calculating delta, we have to put it under the radical over 2a. So this is a rule that should be memorized for x prime. For x double prime, it's similar, but there is a difference here, as if they are conjugates. So x double prime is equal to minus b minus radical delta over 2a. That's why when delta is positive, the roots exist, because we are dealing with radical delta. Okay? And negative values cannot be defined or cannot be put under the radical. It will be an undefined value. So these are to be memorized, and we are going to make training exercises to apply these rules. Now if delta is 0, why do we have one double real root? Let's see. If delta is 0, then radical delta will disappear. Then x prime and x double prime are going to be minus b over 2a minus b over 2a. That's why we are going to have one double real root, because delta is 0, then radical delta is 0 also. So up till now we have two ideas. If delta is positive, then there are two distinct real roots for the equation. One of them is minus b plus radical delta over 2a, the other is minus b minus radical delta over 2a. If delta is 0, then we have one double real root, x prime equals x double prime equals minus b over 2a, and if delta is negative, then there are no real roots. So number of roots is 0, means that there are no real roots. Why? Because I cannot put a negative number under the radical, that doesn't exist. Here is example 1. Solve x squared minus 7x plus 11 equals to 0. A is 1, B is minus 7, and C is 11. We are going to use the discriminant delta to solve this equation. Delta equals, again and again, b squared minus 4ac. Then minus 7 squared minus 4 into 1 into 11. Then it's 49 into minus 44, which is 5. Positive means I have two different real roots for this equation. Then when delta is positive, definitely I'm going to get two different or distinct real roots. One of them, using the rule, is minus b plus radical delta over 2a, which means minus into minus 7, because b is minus 7, plus radical 5 over 2 into 1, which is 2a. A is 1 and 2 is outside. Then we will get 7 plus radical 5 over 2. X double prime is similar to that one, but there is minus in the middle. Instead of plus radical delta, there is minus radical delta. So x double prime is minus b minus radical delta over 2a, then minus minus 7, minus radical 5 over 2 into 1, then it's 7 minus radical 5 into 2. Here is a graph making things clear. Look at this graph. This graph is related to the function whose written as x squared minus 7x plus 11. That's exactly like this equation we solved. When solving a quadratic equation equals to 0 and relating it to functions, that means I'm searching for the number or the roots with that are the intersection points with the x-axis. They are the x-intercepts. So notice here that you surely have two distinct x-intercepts, two distinct points as intersection. These points are of abscissas 7 plus radical 5 over 2, and this is of abscissa 7 minus radical 5 over 2. So these x prime and x double prime are indeed the x-intercepts between a curve, a function whose equation is x squared minus 7x plus 11, and the x-axis. Here is another equation, x squared minus 6x plus 9 equals 0. Here a equals 1, b equals minus 6, and c equals 9. Applying delta, we get b squared minus 4ac gives minus 6 squared minus 4 into 1 into 9, 36 minus 36, which is 0. What does that mean? When delta is 0, then definitely I'm going to have to equal or double root, to equal real roots. X prime equals x double prime equals minus b over 2a using the rule. Then minus b means 6 over 2a means 2 into 1, which is 2, and finally the double root is 3. This equation, x squared minus 3x plus 5 equals 0. Here a is 1, b is minus 3, and c is 5. Delta is b squared, which is minus 3 squared 9, minus 4 into 1 into 5. A is 1 and c is 5 for ac, which is 9 minus 20, which is minus 11. Minus 11 is a negative number, then this equation has no real roots. Let's see things graphically. Here is the curve referring to this equation. F of x equals x squared minus 6x plus 9. Notice that only one root. only one root whose abscissa, the abscissa is 3. That means that x prime equals x double prime, which is 3. Notice there are no two roots as in the previous graph. While here, look at the curve here. It's above the x-axis. It's never intersecting x-axis. That's what we mean by no real roots. There are no x-intercepts.